For as long as we can remember, the idea of a robot takeover has lived in the world of movies and books, a far-off future we never thought we'd see. But that era is over. The race to build humanoid robots is on, and it's moving insanely fast. Every big tech company is suddenly in a mad dash to build these things, and that makes you wonder, when they can actually think for themselves, it's not just about what jobs they'll take, but about what roles we're willing to give up. And leading that charge is a name we all know, Tesla. At their 2025 all-hands meeting, Elon Musk laid out a plan that's as ambitious as it is specific. The goal is to build 5,000 of their humanoid robots by the end of this year. He's calling it the First Legion. And that's just the start. By next year, that number is projected to explode, growing tenfold to 50,000 units. But the real story with Tesla goes beyond these big numbers. It's about the scope of their vision. Sure, the first ones will be working inside their own factories, but they've already shown us glimpses of a much broader future. At We Robot last year, we saw bots that could mix drinks, dance, and have conversations. Now, it's important to be honest. Those robots had some help for the demonstration, but the message was clear. Tesla sees these robots heading into disaster zones where it's too dangerous for people, and they're central to the plan for building a base on Mars with SpaceX. This is about creating a machine for the entire world. And the machine itself, the Gen 3 model, has come a long way from the days when it was just a person dancing in a spandex suit. It even serves popcorn in the Tesla diner. Standing at 5'8", it weighs about 125 pounds and uses 28 different actuators to copy the full range of how a human moves. Now, the hands are where it gets really interesting. They have 22 degrees of dexterity. To put that in perspective, your own hand has between 23 and 27. That means this robot can, in theory, handle any everyday object you can, with what amounts to surgical precision. Its body is loaded with 8 cameras, and it's all powered by the same self-driving AI that's already on the roads in millions of their cars. This brings us to Tesla's ultimate advantage. They have this incredible vertical integration. They don't need to start from zero. They're leveraging years of real-world AI training from their fleet of vehicles. And their own manufacturing expertise means they can build these robots in-house, then immediately put them to work testing and refining the process by building their own cars. Or maybe one day, even helping to build more of themselves. Now, Tesla might be the biggest name, but they are far from alone. This is a global gold rush. Back in 2024, the entire humanoid robot market was valued at a little over $10 billion. But by 2032, analysts think it's going to balloon to nearly $39 billion. This is an entire industry hitting the accelerator at once. While new companies focus on AI brains, we can't forget the pioneers who spent decades mastering robotic movement. Boston Dynamics is the true godfather here. They spun out of MIT back in 1992. Their humanoid robot Atlas has been evolving since 2013. Last year, they unveiled a fully electric version of their iconic Atlas robot, ditching hydraulics for a sleeker, more efficient design. That was impressive, but their new AI system, powered by large behavior models in collaboration with Toyota Research Institute, is where things get serious. These models give Atlas the ability to perceive its environment, plan complex actions, and adapt to surprises, like a box lid slamming shut mid-task, without rigid programming. They've also partnered with LG Innotek for sharper vision sensing. And this technology is already moving out of the lab and into the real world. Boston Dynamics kicked off pilot testing of Atlas at Hyundai's Georgia EV plant this October, starting with part sequencing on assembly lines. Their longer-term plan is to scale across Hyundai facilities and beyond, with full commercialization eyed for 2028. A target like that would have seemed completely impossible just last year. So, what makes these large behavior models so special? Think of it as a unified brain. The first part handles perception and reasoning. It's a vision-language action system that processes visual inputs, text prompts, and environmental context to understand tasks on the fly. The second part is all about execution. It orchestrates whole-body motion, treating hands and feet interchangeably to walk, crouch, lift, and manipulate with 50 degrees of freedom, including dexterous 7-degree of freedom grippers for power or pinch grasps. One half grasps the what, and the other half masters the how across diverse objects, from heavy payloads to delicate items. Perhaps the most staggering thing about these models is how efficiently they learn. They were pre-trained on vast, diverse datasets, drawing from cross-embodiment training and human motion capture, then fine-tuned with just 3 to 5 times less task-specific data than older methods require. That's a tiny fraction of the engineering effort needed for other systems. To see this in action, there's a demo where Atlas, powered by the model, tackles a simulated workshop chore, sorting and packing car parts into totes. It had no special training for this, no step-by-step scripts, just raw vision, reasoning, and whole-body coordination to lift, balance, and adjust to disruptions. It wasn't perfect, but it was competent enough to be genuinely awe-inspiring. That leads to a fundamental question. Who is building the foundation that everyone else can stand on? The answer to that is Nvidia. What Google's Android operating system did for smartphones, Nvidia is now doing for humanoid robots with a project called Groot. Think of Groot as a universal plug-and-play brain. It's a foundational AI model designed to handle a wide range of real-world tasks and adapt on the fly. The real genius of Groot is in its architecture, which works a lot like our own nervous system. It has 2 distinct parts that operate together. The first is a reflex system. This is the instinct. It allows a robot to react instantly to its environment. The second is a reason module. This is the planner. It interprets complex instructions, scans the surroundings, and formulates a strategy. One part handles the immediate now, and the other plans the next move, creating a fluidity that's far beyond traditional programming. But Nvidia's strategy goes far beyond releasing smart software. They are launching an entire ecosystem. They've made Groot open source, inviting developers worldwide to build on it. To handle the physical computation, they've created a chip called Jetson Thor, powerful enough to run the entire Groot system inside a robot's body with 0 lag. They've even built simulation tools and collaborated with groups like Google DeepMind to generate massive amounts of training data at an incredible pace. The result? If you look at the companies building robots today, you'll find Nvidia's technology at their core. Look at China's Unitree Robotics. They're not just building another humanoid robot, they're building a personality. At their new 10,000 square meter factory in Hangzhou, they're scaling up production of the G1, a robot that doesn't just walk, it performs lifelike handshakes, hugs, and waves. But Unitree's real genius has been in marketing through spectacle. They created the world's first robot boxing tournament in May 2025, where G1 models delivered dramatic, remotely operated knockouts broadcast on Chinese state TV. Then, just a few months later, they sent a G1 named Jake the Rizbot to interact with the public in Austin and Venice Beach, charming crowds with a cowboy hat and Gen Z slang, who also showed up in popular streamer Ishao video. They've even shown the G1 executing a real 720-degree roundhouse kick and enduring violence testing to prove its durability in the latest demo. Its secret weapon is an anti-gravity stability system that lets it quickly self-right after being kicked or shoved, absorbing impacts with a predictive balance control. Yet, what's truly crucial is that this viral technology is now moving beyond demos and into real workplaces. Early adopters in manufacturing are already reporting a 30% efficiency boost using G1 units for repetitive tasks. Its compact design is proving ideal for factory floors, car washes, and handling heavy loads in hazardous conditions. In healthcare, researchers at UC San Diego are exploring the G1 for teleoperated clinical support in high-stakes caregiving scenarios. And for the most dangerous sites, like nuclear facilities, its 24/7 uptime and precise dexterity enable it to fully replace human presence for risky inspections. With mass production ramping up and a starting price of just $16,000, Unitree's G1 represents a fundamental shift. It's pairing perfected, robust movement with advancing AI, bringing humanoid robotics out of the viral video sphere and directly into our daily workflow. So, what makes a robot truly humanoid isn't just its shape. It's the ability to adapt and learn in real time. We're now seeing the pieces come together. Boston Dynamics Atlas perfected the athletic body. Tesla is building the first Legion for scale. And Unitree's G1 is proving that agile, affordable, and resilient robots are ready for the real world. But they are being built to work alongside us, and in many cases, to work instead of us. They're not here to replace humanity, but they will fundamentally redefine what we are needed for. If you enjoyed this look at the robot revolution, hit that like button and subscribe for more tech insights. Let me know in the comments, are you excited or cautious about humanoid robots? Thanks for watching, and I'll see you in the next one.